Example 3. This one has to do with scuba diving. Now, scuba divers have to be pretty darn good at algebra because their life depends upon them being able to figure out some functions and actually to rearrange some functions. This formula that we're looking at right here tells us the amount of time a diver can stay underwater, and that time is a function of V and of F. V is the volume of air in their tank. Now, of course, that's compressed air. And F is the number of feet below sea level. All right, let's say we know that the diver is going to be underwater for 10 minutes. And he only has 20 cubic feet of compressed air left in his tank. Okay? This diver wants to figure out how far down he can go. So the basic formula right here needs to be rearranged. We need to go ahead and solve it for F because we want to find out how deep we can dive given, you know, the time constraints and the volume constraints. Alright, so it becomes an algebra problem. We've got to get this thing rearranged so that the F is by itself. So we're going to multiply both sides of the equation by F plus 33. F plus 33. Alright, so F plus 33 divided by F plus 33 here will give us 1. Those will divide to 1. Okay? Now, let's go ahead and just come on right down here and see what it looks like after we've done that multiplication. Here we'll have the quantity of F plus 33 times T is equal to just 33V. Alright, now let's get rid of the T. Let's move that over to the other side by dividing. Okay, T divided by T is 1, and that will now leave us with F plus 33 is equal to 33 times the volume divided by T. The last thing we need to do is remove the 33. It's being added right now, so we're going to subtract 33 from there, and we're going to subtract 33 over here. So 33 minus 33 is 0, and let's see here. So that'll leave us with the number of feet down that the diver can go is equal to 33 times the volume in the tank divided by the time underwater minus 33. Alright, so now that we have the rewritten in terms of F, let's go ahead and see how far down this diver can go with 10 minutes underwater and only 20 cubic feet of compressed air. So we'll substitute in the 10 and the 20. So the number of feet down the diver can go is equal to 33 times the volume of the tank, which is 20 cubic feet. And that's all going to be divided by 10 because that's how long he can be underwater, minus 33. Alright, so the number of feet will be equal to, let's see here, 20 divided by 10 is 2, 2 times 33 is 66, minus 33, so the depth that this guy can go is 33 feet. Example 4 has to do with quadrilaterals. This comes from geometry. If you take a quadrilateral where the diagonals of the quadrilateral are perpendicular, as in rhombuses, kites, and squares, this will always hold true. If your two diagonals are d sub 1 and d sub 2, the area of the entire quadrilateral will always be equal to 1/2 times d sub 1 times d sub 2. Very, very simple little formula. Now, here's a question. What do we know is always true about the product of d sub 1 and d sub 2? Now, to figure that out, all we got to do is rearrange the formula and get the product of d sub 1 and d sub 2 by itself. Okay, to get this by itself, we'd have to remove the 1/2. Well, the way you remove the 1/2 is to multiply by its reciprocal. Its reciprocal is 2, so 2 times the area of the quadrilateral will always be equal to d sub 1 times d sub 2.